Okay. Um, 802.11 is the Wi-Fi standard. There are many versions of this standard, and each version has its own range, frequencies, and speeds. For example, 802.11ac at the bottom is typically what is found in homes today. It is also known as Wi-Fi 5. It allows backward compatibility with 802.11b, G, and N. 802.11 has a range of 70 meters indoors and 250 meters outdoors. And 802.11 AC can theoretically achieve speeds of up to 1.3 gigs, so 1300 megabits per second on the 5 gigahertz spectrum, and 450 megabits on the 2.4 gigahertz spectrum. Although now we have 802.11ax, Wi-Fi 6, and Wi-Fi 6E. They went live in 2019 and will eventually replace the 802.11ac, and 802.11ax 6E, the 6E. When you go looking for new equipment, you're going to want the 6E, and it will replace the 802.11ac, and it will have theoretical speeds of up to 10 gigabits and use less power than 802.11ac. It will be more reliable in congested environments and support better security, although it will have a reduced range. I couldn't find out the range for it. It's fairly new. Standard, like I said, just came out in 2019, but it'll be a little less than the 70 meters. But the speeds are almost 10 times faster. So I can't wait for our to be able to get a Wi-Fi 6E access point. The FCC opened up the 6 gigahertz range for unlicensed use on April 23rd, 2020. This means by the end of the year 2020, we should start seeing the devices labeled as Wi-Fi 6E, and the E tells you that it is the new 6 gigahertz frequency. Without the E, it uses the 5 gigahertz spectrum, and we don't gain the speed. But so being able to use the 6 gigahertz frequency it doubles the frequency that was available in the 5 gigahertz span. This is what allows us to reach potential speeds up to 10 gigabits. So looking forward to that coming out. Like I said, it was the 802.11ax went live in 2019, but it wasn't approved for the 6 gigahertz band until April 23rd of 2020. So it'll take a little bit of time, but it'll start coming out with devices that are now capable of taking advantage of these speeds. Here's an example of a wireless network card that would be plugged into the motherboard on a desktop computer. A common method of securing a wireless connection is by using a security key. Data is encrypted using an encryption standard. You'll use the configure utility for your wireless access point, typically part of your router, to set the key. It is also best to use a different security key than the password used to enter the router, or wireless access point, right? So you definitely want a different password to access the wireless, right? Your security key than what you use to access the access point or router configuration pages. You want those to be different. There are several encryption standards. However, you should only ever use the WP WPA2 or higher. WPA2 is currently the most widely available standard that's available on most devices. So you should be using that, or the WPA3 if that's on your device, and should be on the newer devices, especially these 6Es, the 802.11ax devices, the 6E Wi-Fi 6E devices. As they start coming out, they should come with the WPA3 encryption standard. You should never use WEP or just WPA, also called TKIP. They're not strong enough, they're old, they're weak, they're not secure. All right, the SSID is the network name and is typically broadcasted so that you can select it and connect to a network. That's your wireless network, the name that you see when you click on it to join the wireless network. That's the SSID. However, many devices allow you to turn off broadcasting so as to hide the network, so it won't show up in the list of wireless networks. It is still there and you connect to it. You just need to manually enter in the SSID. On some access points, you can designate which of the wireless frequency channels your radio broadcasts over, and this can be helpful if someone else close to you is using the same channel, because if you're using the same channels, you could be causing interference and have both of you have bad connections. So you can switch the channels and likely gain a better connection. Some access points allow you to adjust the power level of the radio. Wi-Fi is limited to 4 watts of power, including the gain from your antennas. And more power does not always equal a better network connection, as you could receive feedback from your signals bouncing off objects that actually interfere with your own signal, and thus you could gain a better connection by turning down the power. Years ago, I owned and ran a wireless ISP. This was before cable and DSL were readily available everywhere. I set up the wireless ISP so that I could get high-speed network access at home, as dial-up was the only option at the time. My longest wireless connection I set up was just over 5 miles, and it was amazing when I first connected the radios and was surfing the internet on top of my customer's roof, 5 miles from my office where my wireless tower was. My setup was well under 4 watts, including my antenna gain, and I got the distance due to having a 100-foot tower. So my antenna was placed at the top of a 100-foot tower, and thus the radio waves were able to travel over 5 miles with just under 4 watts of power, and I was able to service most of the town in my area off of the one tower. Many access points offer you the option to configure a network on both the 2.4 gigahertz bands and 5 gigahertz bands, and each can have different names and security keys. You can also easily select the channel that you broadcast from, and soon the access points will offer 6 gigahertz bands as well. Just like the wired networks, we can do quality of service, QoS, over wireless by enabling WMM or Wi-Fi multimedia, which will give the priority to packets that are dealing with audio, video, and voice, with just plain data packets being a lower priority, right? WPS, or Wi-Fi protected setup, automatically generates the SSID and security key. Of course, with a hard to guess or remember security key, you will likely write this down, and thus this may be a security risk, and is more risky than probably using a simpler password. But there's pros and cons to both. You might also want to enable the auto disable function so that the network is locked down and no one can use it after a couple of failed attempts. But if you do, just know that a neighbor could actually lock you out if they try connecting to your network on accident. All right. So that is our section on wireless. Our next video will be covering network troubleshooting.